Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. May all the peace and blessings of the Almighty Allah subhanahu wa ta'ala be on all of us. Today, as you can see, I want us to navigate through a question on electrochemistry, a Kcse question that was tested in the year 2019. Now, let's look at the first part of the question. What's meant by the term standard electrode potential? Now, the standard electrode potential, it is the potential half cell relative to a standard hydrogen half cell, where now the standard hydrogen half cell is given an electromotive force, or rather the voltage, which is 0.00. Now, we were given some electrode potential and the EMF. Now, you have this one with an a standard electrode of 1.49 positive, 0.77, 0.34, negative 0.23, positive 2.87, and positive 1.36. Now, the first question you asked is that whether acidified manganese 4 oxide can oxidize M2. Now, let's look. You are given this one, and our M2 is here. So, will it oxidize? Yes, it's going to oxidize. Why? Because when you compare these two, this one has a higher tendency of gaining electron as compared to this. And therefore, when this one loses electrons, this one is going to gain. And therefore, the one gaining electrons is now going to be undergoing reduction, while this one now will be undergoing oxidation. And therefore, we are going to see that this one can oxidize M2. And the reason given there is that manganese 4 oxide can oxidize manganese ion. Reason being, we use the standard electrode potential. The more the positive, the higher the tendency to gain electron. And when it gains electrons, it is going to undergo reduction. On the other hand, the other one, which is losing the electrons, is also undergoing oxidation, and hence it is getting oxidized by manganese 4 oxide. And that is briefly about that question. Select two half cells which when combined will give the highest EMF. The one that will give you the highest EMF, which you check the negative one and the most positive one. The most positive is this one, while the negative one is this. This one is going to undergo reduction, while this one is going to undergo oxidation. This one has higher tendency to gain electrons, whereas this one has low tendency to gain electrons as compared to this. And now when you join a half cell of these two, you are going to find out that this one is going to gain electrons, as this one is going to lose electrons. And when you want to find the highest EMF of a cell, you get the highest positive and the one with negative, the lowest, or rather the highest negative, the one with negative to the highest value. In this case, we have positive 2.87 and negative 0.23, and that is the cell Q and the cell P. And therefore, we said Q2 and P are the ones that when we connect that half cell, they are going to give us the highest EMF. Let's continue. Write the representation of the cell in B2 above. Reduction, oxidation. Good. You have written that one as this, very simple. Let's go to the EMF of the cell. The EMF of the cell is gotten as E reduction minus E oxidation. Our E reduction is positive 2.87 minus into bracket minus 0.23. Minus is going to get positive. Now the overall EMF for the cell will be 3.10 volts. Now I want us to look at the question about calculation, and I want us to deeply analyze this question, then we get the answer together. Now we're told a mass of 1.24 grams of a divalent metal was deposited when a current of 6 amperes was passed through a solution of the metal sulfate for 12 minutes. determine the RAM of the metal. Very good. Now for us to solve that question, we need to understand, the first thing we need to get is, we need to get the charge Q. Charge Q is equals to IT. Charge Q is equals to IT. Our current is 6 times 12 times 60. In this case, we need to convert it to seconds. So 6 times 12 times 60, 6 times 12 times 60, we are going to get 4320 coulombs. 4320 coulombs. Remember, we were told that our metal is divalent. And when we are told our metal is divalent, what we know is that the charge of a metal is always positive, because metals do lose electrons and they form positively charged ions. And when it is a divalent, it means it has a charge of 2. Therefore, we can get M2 positive plus 2 electrons to form metal solid. Now from there, how do we proceed? Now we have the mass. We have the mass. Our mass given is 1.24 grams, equivalent to 4320 coulombs. On the other hand, 1 Faraday is equals to 96,500. Now here we have 2. What about 2? Now it becomes 2 times 96,500 over 1. 96,500 times 2. Now it becomes 19,300 coulombs. Now we say, what about 19,300 coulombs? So that we can get the RAM, because the RAM is what we are looking for. Now we're going to find 19,300 times 1.24 divided by 4320 times 1.24 divided by 4320. Now we're going to find 55.4 grams, and that is the mass of the relative atomic mass of the divalent metal. And the last question is state 2 applications of electrolysis. Number 1 is electroplating. It is used in electroplating. And number 2 is extraction of reactive metals. Extraction of reactive metals. And that is briefly about the question. For more, dive deep into our educational YouTube channel. Wish you all the best. Thank you.